Next question for you guys is, how do we currently assess remyelination in human studies, and how are we working towards improving the assessment of remyelination, especially now that we do have a few clinical trials currently ongoing?
All right, I'm gonna
Yeah.
let you lead this one.
Yeah. Um, this is a major critical question for the field. And the truth is, across medicine, the only way you develop tools for assessing whether or not something works is to actually have drugs that can modulate a disease and then measure whether or not what you hypothesize will measure will record or reflect uh, uh, the biological effect you want to have, the improvement you want to have, is actually seen. So it's an iterative process. And we have learned via doing clinical trials that there are tools that may be useful. So the different tools include functional measures of how quickly electrical signals are transmitted in the brain. This is one of the things myelin does. Second thing myelin does, as Paul was touching on, is it keeps axons alive. So can we measure over longer term periods whether or not axons survive? And lastly, it's possible that imaging tools may be capable of measuring myelin, but we have to really do measure that, assess that in a very careful way. And I would just reflect on, I mean, there is, sure Paul may have seen it as well. There was recently a paper that made a claim that a myelin imaging technique recorded the fact that people who run marathons were actually demyelinating their brains when they ran a marathon and recovering afterwards. Now, I'm going to give as much credit as I can to the authors of that study, but say that is totally implausible to those of us in the myelin field. Like, none of us fundamentally believe that people are at a global level demyelinating their brain. And it's the wrong inference to have drawn from a tool or a technique that may partially reflect myelin, but could reflect other things as well, to make the mistake that it only uniquely reflects myelin, which is why we have to do this carefully, iteratively, and in a way that aligns with what we understand at the biological level from scientists like Paul and others in the field who really, who really at a detailed level understand the biology of myelin and how recovery of myelin may be reflected both in either increasing the speed of electrical signals, keeping axons alive, or restoring function.
I mean, obviously, as Ari touched on, the MRI-based imaging methods are useful, but are indirect measures of remyelination. And I think there's still a lot of potential for increasing specificity and sensitivity there with imaging, whether it's high-resolution MRI or PET tracers that might be able to more directly visualize myelin. The functional assessments, Ari and colleagues have really used visual book potentials and others, I think very effectively. And what is currently the field standard for looking at remyelination, but it assesses, the visual system solely at the moment in MS patients. And so there's, work to be done to understand how we can more directly measure remyelination. I think an opportunity, still early stage, but thinking about, biomarkers, are there blood or CSF proteins that could reflect not just myelin loss or neurodegeneration, things like neurofilament light chain, for example, but could we actually detect the formation of new oligodendrocytes? And remember that oligodendrocytes as a whole are very long-lived cells in the body, and so when you're regenerating new oligodendrocytes, there should be pretty low background in that signal of a new oligodendrocyte. And so in the context of a disease, is there a marker that we might be able to identify in the blood or CSF or even circulating RNAs, for example, that might be able to more directly indicate oligodendrocyte regeneration and remyelination? So I think those are some of the challenges as well as the opportunities for us in this space. And as Ari, very nicely said earlier, I think until we identify an effective remyelinating therapy, it's hard to know conclusively which of these assessment methods are best and which might actually predict meaningful clinical outcomes for